Hello everybody, my name is Cody. I'm here with the Emerald Coast Science Center. I'm an educator here. We understand that y'all want to stay hunkered down in your houses. We respect that. And we just want to make sure that we're giving something that y'all are used to in this time where things are kind of hectic. But what we're going to be doing today is we're going to be doing an experiment. We're going to be scientists. So we're going to see, you can grab whatever items you have around your house. We're going to see what sinks and what floats. So in order to do that, I'm going to go ahead and talk about sinking and floating. Sinking is the ability for something, when you put it in a liquid or whatever, it sinks down to the bottom, it'll fall down to the bottom to where it'll rest at the very bottom. And then floating is where it's going to stay on the surface or near the surface, right? And so I have a bunch of items that you can see and a couple sub-experiments that we're going to do inside this whole thing. So it'll be pretty fun, and this is something that y'all can work with us back at home, because we know there's not really a lot going on right now, right? So this will be fun. All right, so I'm gonna go ahead and get started. Let's see, what item do I want to use first? I'll use a rock, all right? What do you think the rock's gonna do? This is the easy one. What do you think the rock's gonna do? It's gonna be loud. It sunk, right? So it is more dense. So we can talk about density. Density is the amount of units per area, right? So a rock's really compressed. It's got a lot of weight, grams per area, surface area. And so the lighter density it is, the more it's going to float, right? Gas is a lighter density. My hands are wet. I'm going to have to wipe it off. Gas is a lighter density, so it's going to float up into the air. Solids are usually more dense, and then liquids are in between, right? But there are some instances where some solids are going to float, and we're going to find out why. We're going to see it. So let's go ahead. What about the golf ball? What do you think of the golf ball? You think it's hollow? You think it's got anything inside of it? Let's find out. So it sunk, right? Didn't go as fast as the rock, so it's not as dense, but it still sunk. It's more dense than the water, right? And so water has a bunch of cool properties that allow us to do a bunch of different experiments with them. Let's see, what next? Oh, I got one that's gonna trick y'all. Hopefully it'll trick y'all. All right, so that's apple. Think it's gonna sink or float? Let's find out. It floats. Nice, so it's not as dense, right? When you bite into an apple, you can kind of feel the empty spaces in there. Yeah. So that's pretty cool. I'll save the apple for later. I'll eat it for lunch. All right, let's see what we got next. Softball. You can use a baseball too. Same thing, pretty much. See if this floats or sinks. What do you think? Keep in mind, y'all are more than welcome to comment what you think is going to happen. We want y'all to be interacting with us because this is just a big thing that we're able to work with the community. We want to stay interactive with y'all in this crazy time.
Someone said it's going to float.
She's gonna float. Nice. Let's see. You were right. You're right. It's floating. All right. Let's see what else I can do. Okay, I got this really heavy ball. I'm just kidding. It's not heavy at all. It's pretty light. Not sure what kind of metal it's made out of. But do you think metal floats? Let's see. It's floating. So you can kind of feel, you can kind of hear maybe it's a little hollow inside. There's trapped air inside of it. So if the air is less dense, it's going to cause the ball to stay afloat, right? If it was fully metal, it'd probably sink down to the ground. Let's see here. This one's going to be good. All right. 7-Up can. What do you think is going to happen? It is still closed, right? I'll wait a little bit. Let's let people try and figure out what is going to happen to it. What do you think is going to happen? Do you think it's going to float or sink? Okay, let's go ahead and try it. It's floating. So inside the can, we have that trapped gas, right? The carbonation in there. It's floating, but once I release it, you hear the gas enter out. Exit out, I mean. And then I'm going to put it back in there. And it's going to sink. All that gas is gone. It's sinking. Now I got 7-Up and water in here, but it's okay. All right, put this off to the side. So we wanted to make sure we had some equipment that you could easily find around the house. That way you can do this with the kiddos. So you can kind of have fun with it. You can kind of make it your own experiment. See what's going to float or sink. Think the dinosaur's going to float? He's got little arms. Might not be able to paddle. I don't know. See what Mr. T-Rex does. No, he's sinking. Yeah, he's got those little arms. He can't paddle that well. He's going to sink. There's no, it's not hollow inside also, so that's, if it was hollow inside, it'd probably float a little bit because it's got that trapped air inside. We've got a marble right here. Ooh, and got a little shell. So there's a gastropod shell. Let's try the shell first. Shell's got some trapped air inside of there. So if you look, you can see the little cracks right there. That's got some trapped air inside of it. But if I turn it over the other way, let some of that air out. Let's see if we can get all that air out. It'll be kind of hard to get all that air out. Let's see here. Let me move this out of the way. There we go. Sinking. Nice. All right. So we showed y'all good. Ooh, we didn't show you the wooden block. Wooden block. Not sure if it's hollow inside, but we can test it out. Wood floats, right? We kind of all knew that. All ships were made out of wood back in the day. They're not made out of wood anymore. They're made out of metal, which is heavier, which people think, how is that possible, right? So when things are, like say a boat, if a boat is going into the water, the lighter it is, the more it's going to stay towards the surface, right? But a big metal boat, like a big cruise ship, is going to sink all the way down into where buoyancy is a force, right? So the buoyancy is going to push back up, and once the force of buoyancy, once it gets low enough, it gets stronger. And so as that ship is sinking, the buoyancy is pushing up until those forces are equal. And that's what's going to cause that boat to stay afloat, right? Until surface tension breaks, which we'll talk about surface tension in a little bit towards the end. So right here, I'm going to do a little cool experiment. We have some water right here, and we have an empty beaker. But what I'm going to pour in that beaker is vegetable oil. Okay, so I'm going to pour these liquids together, and some of y'all might be thinking, well, that's no use, they're both liquids, they're both just going to mix, right? Well, if you thought that, you'd be wrong. But that's okay, scientists are wrong all the time. We just learn from our mistakes, right? So, I'm going to go ahead and pour this liquid in here first. You gotta be real careful, don't want to make a mess. Actually, I'm gonna do something a lot cooler. Let's go ahead and pour the water in there first. No, I'm gonna go ahead and pour I'm gonna go ahead and pour the oil in there. All right. So I got a good amount of oil. You can see that all right there. It's got a nice yellow color. What do you think is gonna happen once I pour this water in there? You think it's gonna mix? You think it's gonna stay at the top? You think it's gonna go to the bottom? What do you think is gonna happen? I'll wait a little bit. Dun 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 dun. All right, we're gonna do it. All right, ready? So you gotta be real careful, because if you pour it kind of willy-nilly, you just go ahead and pour it all in there, it's gonna mix and create air bubbles, kind of like it's creating air bubbles right there. But you can see it's going all to the bottom. All that water, it wasn't creating air bubbles. All that water is going straight down to the bottom. So the oil is insoluble, right? So it's not able to mix with the water, right? So oil is known to be insoluble with water. Water is able to cause a lot of compounds to mix together with it. You know, salt water is soluble in water, and so whenever you pour a bunch of salt in there, you can mix it around and it'll dissolve into the water because it is soluble. It's able to cause reactions with the molecules, but this oil is not, right? This oil is insoluble, so that's how it's able to separate like that, which is pretty cool.
So does that mean water is more dense, or the oil is?
So since the oil is on top, right, it is less dense. The water is more dense. I should have said that earlier. Thank you for catching me. So yeah, that's why I poured the oil first and then the water second, because I wanted to show you that the water is going to go all the way down to the bottom because it sunk, right? The water sunk because it is more dense than the oil, which is pretty cool. All right, and this is going to be our last little experiment. This is one of our sub-experiments. You can see I have a nice little Lego boat that I made. A lot of y'all have Legos back at home, so this is something that you can do. And then I have this dish right here, this plastic dish. The structural integrity of these Legos is probably not as great as this dish. There's some cracks in here, right? There's some cracks in the Legos. So some water might seep through. And what we were going to talk about before we start this is surface tension, right? So water has a really strong surface tension. Water is super attractive to, the water molecules are super attractive to one another. Over here you can see I have some water molecules, and this is how they stick together through surface tension, right? So we got H2O, 2 hydrogens and 1 oxygen, right? Hydrogen is a positive atom, and then oxygen is a negative one. So whenever there's a bunch of water molecules, say in the little pot there we have, the little jar, they're all going to form together, right? It's on the surface. So the positive hydrogen, opposites attract, right? There's going to be a strong a hydrogen bond right here between the hydrogen and the oxygen. And the oxygen is going to be there, and then the hydrogen is going to bond to the oxygen here, hydrogen to the oxygen here, hydrogen to the oxygen, forming a pretty strong little surface that allows things to float, right? So that's one of the things that's one of the forces that help out in floating. Let's go ahead and see. We're going to put pennies in these little boats that I have. We're going to see which one works better, right? So let's do the Legos first. I want to do the Legos. So hopefully our little Lego person doesn't sink and drown. We're going to put that little Lego in there and it floats, right? But for how long is it going to float? So we have those Legos and there are some cracks in the Legos, right? You can't make the Legos completely perfect. You got to connect them a little bit, and there's going to be some gaps. So once I start putting these pennies in here, it's not going to last much longer. We got 2 pennies. It's already starting to sink a little bit. Oh, that thing fell off, sorry. 4 pennies. Oh, it's not looking good. Oh, goodness. 6 pennies. Oh, it's going down.
Oh.
Yep, she's going. All right. So as you can see, we have sunk our little boat that I created. I worked really hard on it. It took about 2 hours. No, I really didn't. But anyway, so you can see we have these cracks in the making of the Legos. So the water is probably going to seep in through there, and that breaks the surface tension, right? So that's going to cause the water to separate, right? So it'll probably seep through the cracks. So maybe some oxygen molecule is going to go that way, and some other are going to go that way. It's going to break that hydrogen bond, and it's going to cause it to sink, right? So I started putting those pennies on there, and the weight was too much for it. And like I was talking about the boats, so it's going to keep sinking until the buoyancy matches it, but the water got overflowed into the boat, and that's just going to cause it to sink all the way, right? Now we have this solid dish right here, no cracks, right? So I think we're only able to put about 6 pennies, 6 or 7. I couldn't remember, I didn't really
It was
count.
5 before it sank. And
Oh,
then
okay.
6
Oh, okay.
sunk it.
Okay, cool. Thank you. All right. So we got that dish in there. We don't have any water in it, right? So that's a good thing. Let's see how many pennies I can put in here. I'm gonna grab all these because I think it's gonna be a lot. All right. Put it in the middle here. You ready? 1, 2, 3, 4, 5, 6, 7. Now, if you watch the little dish, it's going to start sinking lower and lower because the weight is getting more, right? It's like we were talking about with the boat. So it's
We have
getting.
some guesses. Some people add. Asher says 10 pennies.
Oh,
Tobias
nice.
says 10, and Timothy says 12 pennies.
Nice. Hey y'all, it's good to hear from you. I'm glad you're all watching in the video. All right, so I have 1, 2, 3, 4, 5, 6, 7, 8 pennies right now. Let's see how much we can do. I think it's gonna be a lot. I'm gonna try and space them out because it's gonna start leaning. But you'll notice how the boat is slowly sinking down in the water. It's not sinking all the way yet. How many pennies do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Ooh, it's getting higher. Do y'all want to make some other guesses? 16, 17, 18, 19, 20, 22, 23, 24. Ooh, it's getting close. 25, 26, 27, 28, 29, 30. We're learning how to count today. 31, 32, 33, 34. 34 pennies still.
Annabelle says the dish wins compared to the Lego boat.
That is very true. The dish is definitely the better boat than the Legos. Alright, I got a lot
40
of
pennies,
40 pennies?
says Lindsay. Yes.
Alright. Where are we at right now?
34.
Okay, 34. I forgot. That's not good. 35. See, I'm not that good at counting, I guess. 36. 37. 38. 39. 40. We're still going. 41. 42. 43. 44. 45. Oh, it's about to go. 46. 47. 48. 49. 50. Oh my gosh, I'm so close. Oh, I just dropped a bunch. I think I dropped 3. So 53, 54, 55. Oh, the wire's going in. 55 pennies. Now I gotta clean that up. So yeah, so those are some cool experiments that you can go ahead and do at home. We want to kind of make sure that we're able to interact with the community. At a time like this, it's pretty crazy. The museum is closed, unfortunately, but we still want to be interacting with y'all. Want to be cooperating with y'all so that y'all can have some things to do at home, some cool little experiments, some things you can watch some videos. We have some creature features going on. I will actually be here tomorrow at 10. I'll be doing a creature feature. I will do Alex, our tarantula, and I'll do another creature, but I'm not going to tell you. That one's going to be a surprise. But yeah, so we're trying to cooperate with the community as much as possible, but the museum is closed, so we really do need as much help as possible. So if you would like to donate, you can go to our website. You can donate just so we can stay working with y'all so that y'all can have some fun things to do at home. So yeah, just be sure to stay tuned for tomorrow. Tomorrow at 10 o'clock a.m. I'll be here. Bye.